To multiply and divide numbers in decimal forms, you need to count the number of negative signs in the operation. If there is an odd number of negative signs, the answer will be negative. And if there is an even number of signs, the answer will be positive. How do you guys feel about that pink pen? Is that good? Is that bad? Is pink okay? All right, as long as you guys can see it. You don't have to have an opinion. This is really, I zoomed in because I was doing graphing with my grade 12s. Now I'm all screwed up. All right, so we're going to find the product for the following numbers. Ooh, this is another thing. My goal is to teach you guys kind of the math language, the new language of math. I do a lot of things, like when I'm doing the distributive property, sometimes I'll give it a nickname like leapfrog. But it's really important that we know the real mathy name for it, like vertices are the corners in a shape. So I think part of my job is getting the language down for you guys. Parentheses, do you guys remember order of operations? Bed math, okay? Some people do ped math. First one in bed math is brackets. Parentheses is another name for brackets. I researched this because I'm kind of a geek with this sort of stuff, and brackets are a certain type of shape. But for right now, we can interchange those. Parentheses, brackets mean the same thing. So parentheses is just the exact same word for brackets. And we talked about that a little bit when we were doing like common denominators. We did common denominators. I put like x and then the number that we were multiplying by, and sometimes I use brackets. They mean the same thing. They mean to multiply. All right, so we're going to find the product. So product means that we're doing the act of multiplication. We're doing the act of multiplication. So I don't expect you guys to know your times tables to like the 20th factor. So you can definitely use your handy dandy calculator. I laid mine down over there. Luckily, I've got lots of calculators. If you don't have a calculator, chances are I have an extra one. Okay, when we're multiplying three things together, really what we're going to do is we're going to multiply the first two first. So 8 by 12. I learned that language from my students. I say 8 times 12, but some of my students who are from another country often do 8 by 12, and I kind of like the way that sounds. So I don't know what 8 by 12 is right off the top of my head, so I'm going to use my calculator. 8 times 12 is 96. Did you guys know that? You guys knew that? You guys are good. This is why I like you. 96. So we know the product of 8 times 12 is 96, but now we still have to multiply it by -2. Okay. I turned on the light just so we could see my calculator a little bit better. And then it washes this out. Let me grab a different color. There we go. We'll go with green. So when we're talking about signs, here these were both positive, so my product was positive. But how many negatives do I have? I've got one negative sign. So I know my answer is going to be negative. Now I can let my calculator do the work for me, or I can just know that. So 96 times -2. So I'm going to go times, so it's taking my answer, the 96, times -2. That's exciting. And then equals. And then my calculator tells me that my answer is negative. But I knew it should be. And lots of times, like even in my grade 12 class, I give little hints on how to check. Like if you know stuff about numbers, you know if your answer makes sense or doesn't make sense. You have to be smarter than your calculator because calculators do all kinds of weird stuff. You know your answer should be negative, so this should be negative. If this came out as a positive, I'd be like, that doesn't make much sense. Let me try again. Okay, here we go. So now we have, I can do this one in my head, 3 by 11, negative 3 by negative 11. How many negative signs do I have? 2. So is my answer going to be positive or negative? Positive. So hopefully I get a positive 33. Do you all agree with me with that one? I did the math all in my head. But I'm still not done because I have to times by negative 2. So how many negative signs do I have now? Now I just have the 1. So what should my answer be? Negative. And it's going to be a negative 66. So if we go back up to here, just the actual questions, how many negative signs do I have? 1, 2, 3. And is 3 odd or even? Odd. So based on what we did up here, odd number of signs, my answer is going to be negative. So my answer is negative, so I did it right. Look at me, proud of myself. This one, I don't like the way it's written, makes me sad. If you're going to use brackets, put brackets around every number. I would have written it like this, but it's good to see stuff in all different forms. Because then once we get used to seeing it in different forms, you're like, oh, I know what that means, right? So we're going to go ahead and I'm going to use the same procedure here. Negative 7 times 9. Will my answer be positive or negative? Just between these two numbers. It should be negative. And 7 times 9 is 63. Good job. But we have that negative sign, so it's going to be a negative 63. And we still need to times it by this guy right here. So we're going to times it by negative 4. So, anybody? How do you guys do this in your head? How do you do the tough stuff in your head? Do you guys have a strategy? You stack them and multiply them? Okay, and I do like 60 by 4, and then 3 by 4, and then I add them together in my head. That's how I do it, because stacking them in my head, I can't keep track of numbers. Yeah, we'll talk about that because we're going to use all kinds of different strategies. And again, it has to be one that makes sense to you. Just because I do it doesn't mean it's going to work for you guys. But I like seeing all your thinking. Okay, so negative and negative. 2 negatives, so it's an even number. So we're going to end up with a positive answer. Do I need to write a plus sign here to indicate positive? No, I don't. If you do, if that makes sense to you, then write it down. Like, it's completely correct. 63 times 4. So I'm going to do it in my head. 60 times 4 is 240. And then 3 times 4 is 12. So 240 plus 12 is 252. I'm going to try that on my calculator. 63 by 4. 252. Look at me. And we know it's positive. So 252. So that's one way of, one strategy. And stacking them and multiplying is awesome. I need a pencil and paper to do that though. All right, dividing. How do we feel about dividing? Do you want to do old school long division or do you want to use our calculators? Sure. Do you want to wait till the lesson's over, or if you can't, go if you need to. Like, I don't want to stop you. Old school long division, or do you want to do calculators? Calculators? Fair. Old school division. It's old. It's long. It's good to know how to do it. It's totally good to know how to do it. Like I said, the more you know about numbers, the more it makes sense. Same rules apply for division. How many numbers do I have here? Or how many negative signs do I have here? 1. So will my answer be odd, or will be negative or positive? Negative. You guys are so smart. I'm having a hard time with language. So in our calculators, we put it in as we see it. So we're going to put in, I'm half off the page, 172 divided by, and this is where you want to use, you can use brackets. Most scientific calculators will have brackets. And then I'm going to use my negative button, and then 4, and then I'm going to close my bracket. So what I'm putting into the calculator looks exactly like what's on the page. And the reason why I do that is because it's more likely to work out, but it's always this number divided by that number. You write it in your calculator the same way. And I get negative 43. We knew our answer should be negative, so that makes sense that our calculator did that. So is this one going to be positive or negative? Positive. I'm just going to write positive up here. And what about this one? Should this one be positive or negative? Number 12 should be negative. All right, 56, negative 56 divided by negative 7. Can you guys do that one in your head? Can you? 8. Sweet. So that one is in that, do you guys remember those times tables, like 10 by 10, and it had all the factors in it? Like, so if you're good at remembering that, and some people can't remember, it's not their strong suit, that doesn't mean you're bad at math, it just, you struggle with remembering. That's why I thought we could do this one. We can probably do this one as well. 64 divided by 8, or negative 64, sorry, divided by 8. 8. And you guys see, like, I'm like 64 divided by 8. I don't even look at the signs because I know my answer should be negative. So I need to put my negative sign in there, right? Like, that's the important part. And I mean, we have a handy dandy calculator we can use as well. And I would encourage you to use your calculator until you feel comfortable not using your calculator. And I think some of you maybe didn't use your calculator yesterday. And that's okay. But there's no, I use my calculator all the time. And I do it sometimes even when I think I know the answer and I just want to check. Okay, to multiply fractions, you simply multiply the numerators and the denominators together. And the remaining fractions. Simplify. To make numbers smaller and easier to work with, you can simplify the fractions prior to multiplying. Cross-reducing. You can remove a number between any numerator and any denominator prior to multiplying fractions. You guys are like, hey lady, I don't know what you're talking about. And that's okay. This one's hard. And you know what? I did it with my grade 12s. And they were like, that's magic. Why did no one teach us this before? Okay, so let's do this straight up, and then I'm going to show you how to do it. So let's just do some math over here. When you're multiplying fractions, straight across the top, straight across the bottom. So 2 times 3 is 6, and 9 times 8 is hopefully 72. And then if we want to reduce that fraction, we want to get it in its smallest form, we have to be able to take out or divide, like that's the math that's happening. We need to divide out a number. So what is 6 and 72 divisible by? Right off the top of your head. What number divides evenly into 6 and 72? Maybe 2? Would you say 2? Does 2 go into 6? Like, can we divide 6 by 2 and get a whole number? Yes, we get 3, right? And 72 divided by 2? We get 36. So this would be 3 over 36. Okay, looking at those numbers, can I reduce it further? Can I take 2 out of the numerator? Does 3 divide by 2 evenly? No. But 36 does. Boo. Okay. Does 3 divide by 3? Yeah. Does 36 divide by 3? Yeah. So really all I did here was I divided by 2, I divided by 2, divided by 3, divided by 3, and then 3 divided by 3 is 1, 36 divided by 3 is 12. I can't go any lower than that, so that's my reduced fraction. And some of you might have been able to see right from the beginning that 6 went into 72. And that is amazing. But I usually stick with like 2s and 3s when I'm trying to figure out factors to take out. Okay, now we're going to talk about cross-reducing. I'm going to go back to my pink pen. So with cross-reducing, before having to do all of this here, I can do a bunch of stuff before. I can look at 2 and 8. Can I reduce those numbers as if they were their own fraction? What factor could I take out of 2 and 8? I can only take out 2. I can't take out 4. I heard 4, but I can't take 4 out of 2. 2 doesn't divide by 4. So I can take out 2. So if I divide by 2, what am I left with? On top here, I'm left with 1. And I'm left with 4 on the bottom. So what this allows us to do is reduce them even before we start. And then if you look at 3 and 9, what's the factor I can take out of there? They both share 3, right? So I can take out 3. And when I talk about taking out the math, I guess I should put that on the other side. When I talk about taking it out, really I'm just trying to divide out the factor. So I'm going to have 1 over 3 times 1 over 4. And when you multiply those, straight across the top, straight across the bottom, you get the exact same answer. So as you practice this skill, this will help make things go a little bit faster. Notice you get to the exact same answer. So whatever path you choose, whatever strategy you choose, it's perfect. It doesn't matter. This sometimes is easier when we're dealing with really big numbers. But I can look at this right away. 12 and 4. So it has to be numerators and denominators. It has to be a pair of numerator and denominator. You can't do denominator, denominator. That's bad. And you can't do numerator, numerator. Has to be top and bottom. So does 4 go into 12? Yeah. So we can make that, and this is how I do it when I get good at it. I change that to a 1 because I divided that by 4. And I divided that by 4, so I change that to a 3. Let me get, that says divide, sorry. So 4 divided by 4 gives me 1. 12 divided by 4 gives me 3. And now I'm going to do the 5 and the 25. What am I dividing by here? 5. That's the factor they share. So 5 divided by 5 is 1. 25 divided by 5 is 5. So those numbers got reduced. So I have 1 over 3 multiplied by 1 over 5. But hey, wait a minute. There was a negative sign. Can't forget that. That goes back in. So now, straight across the top, 1 by 1 is 1. 3 by 5 is 15. How many negative signs do I have here? Still 1, so it's odd, so my fraction is negative. And you could put that negative, say negative 1 over positive 15, or you could do positive 1 over negative 15. All of these answers mean the exact same thing. But you guys know that. That you guys know. Okay. First step. We have to convert that mixed to an improper. Can you guys go ahead and do that? Everybody give it a shot. I'm going to do it right after. So just do this one to an improper fraction. Pardon? No, I want you to throw that negative sign to the side for a sec. and it would be negative 6 over 5. Okay, so I think we struggled a little bit with this yesterday. When I'm changing this from an improper or a mix to an improper fraction, I want you to hang that on the shelf for just a minute. Just put that negative off to the side for a minute. And so the way we do it is 5 times 1 is 5, 5 plus 1 is 6. So that's 6 over 5. Now you pick up that negative off the shelf and you put it back. And then that's going to be times 7/3. Okay, so when we're converting negatives, it's so straightforward when it's positives, and that's what we like to do. But when we're converting these, we just pick that negative off, we put it off to the side just for a second. We pick it up, put it off to the side. Because really, this negative says the whole fraction is negative. So this is saying the 1 is negative and the numerator is negative as well. So it's a little bit confusing. But I like to just pick that negative up and put it off to the side and then put it back on later. Can I cross reduce here? Can I cross reduce on this one? I think I can. 6 and 3, yep. So what factor do they share? What factor can I take out? 3. So if I divide 3 by 3, I get 1. And if I divide 6 by 3, I get 2. Look at that. Didn't show any math. Just did the math in my head. Can I do anything with the 5 and the 7? No. What kind of numbers are 5 and 7? Prime. Because they only have 1 and themselves as their factor pairs. All right. So now, how many negative signs do I have? Just the 1, so I know my answer will be negative. So now I have 2 times 7, 14. 5 times 1 is 5, but I know my answer should be negative. Cross-reducing, although probably seems a little weird right now, is super handy when you get into bigger numbers and more complex stuff. Okay. We good? If you have to go, Edith, you go. Dividing fractions. So here's the thing. We don't like to divide fractions. We change it to a multiply, and what do we do to that second number? Do you guys remember? Have you ever heard of the word reciprocal before? Yeah, maybe, kind of, sort of, or this just means to flip the fraction. So you keep the first fraction, change your operation to a multiply, and you flip the second fraction upside down. You use the reciprocal. Mathy words. Oh, okay. You know what? We're going to start with number 2. We're going to start with number 2. Oh, and the positive negative rules still apply. Okay, so here we go. So we keep the negative 7 over 10. You see how I moved that negative right up to the numerator? I don't know why I did that. I just did. It's okay. It's the same thing. So I change this to a multiply, and then I flip this one. So the reciprocal is 6 over 5. Okay, so now it's just a multiply thing. Can I cross reduce? I can. I can't do 5s because those are both denominators, but is there something I can take out of 6 and 10? 2. So if I divide 6 by 2, it's 3, and if I divide 10 by 2, it's 5. And we just said that these are prime, so there's nothing we can do there. So negative 7 times a positive 3 is a negative 21. 5 times 5 is 25. And if you cross reduce, you don't have to reduce again. Okay, I want you guys to do number 3. I want you to try it. I want you to try it. And I'll do it. I'm going to freeze the screen so you can't see what I'm doing. And you guys just give it a try. Use your pencils so we don't mess anything up. So you're going to keep that first fraction, change the operation to a multiply, and flip the second fraction. Look to see if you can cross reduce, and then multiply straight across the top, straight across the bottom. And if you're not sure what they multiply to, definitely use your calculators. It's a tool. It's a helping tool, and it's super helpful. I do math every day for a living, so I know some stuff a little bit more easily, but it's only because I've been teaching for 20 years and I've been teaching math. It wasn't this easy when I was first learning it. Okay, you guys ready to see? Do you need a few seconds? Could I cross reduce anything? 7 and 11 are prime numbers. 6 isn't prime, but 5 is. So I couldn't cross reduce anything, so it was just straight multiplying. Did you guys get this answer? Yeah? Maybe? Okay, it's okay if you didn't. Okay, we're gonna go back to example number 1 before I stop talking. So this one again, you need to change that mix to an improper. This time it's positive, so it's super easy. 3/4, divide it by, and I'm just gonna change this. So 2 times 8 is 16. 16 plus 3, so it'd be like 2 times 8 plus 3 all over 8. So that's gonna be 3/4, divide it by 19 over 8. All right. So now we're going to do keep the first fraction. It stays the same. Multiply by 8 over 19. Anything I can cross reduce there? 4 and 8. We're going to take a 4 out of each of them. So 4 divided by 4 is 1. 8 divided by 4 is 2. And we're going to multiply straight across the top, straight across the bottom. So we've got 6 over 19. And my answer should be positive because there was no negatives in this one. I really like cross reducing. Like I said, some of my grade 12s didn't even know. Seriously, if you ask my grade 11s, some of them were not aware of cross reducing. My current grade 12s were my 11s last year, so they're coming in next. You can say, do you guys know how to cross reduce? And they'll probably look at you like you have 10 heads because they don't know what it is. But if you showed them, they'd know what it is. All right, that's it for me.